Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 27 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That is straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of lessons. And in this class, we will be using the Sunfounder Raphael Raspberry Pi Kit. The Sunfounder Raphael Raspberry Pi Kit. Most of you guys probably already have your kit. If you don't, look down in the description. There is a link over to Amazon and you can pick the kit up. And believe me, your life and my life will be easier if we're using identical hardware. Sunfounder, putting the tech back in TopTechBoy.com. But enough of this shameless advertising. Let's jump in and talk about what I am going to teach you today. And what I'm going to teach you is I'm going to teach you how to add sound to your Raspberry Pi projects. And the easiest way to do that is with buzzers. All right. Now, there are two different types of buzzers. There are active buzzers and there are passive buzzers. Okay, so let me move over here and kind of show you our overhead view of our Raspberry Pi. Let me get out of your way. And what you can see is there are two different types of buzzers and you have two each in the kit. Now, they pretty much look identical. Okay, they pretty much look identical, but let me tell you how you can tell the active from the passive buzzer. The active buzzer has this little tape, this little piece of tape over the top of it, and the passive buzzer does not have the piece of tape over it. They are almost identical other than that. But what you can see is we're going to take that piece of tape off when we start using it. But if you look at the underside of the buzzers, the active buzzer is sealed and the passive buzzer is open. You can see the little circuit board on the passive buzzer. So that's how you can take them apart, tell them apart after you take the tape off of it. Another way that you can tell the difference is, well, let me tell you kind of functionally how the active and passive buzzers are different. The active buzzer is very easy to use. If you put 3.3 volts on it, it buzzes. If you take the 3.3 volts off, it turns off. So an active buzzer is very easy to use. It is on or it is off. And so the easiest way to incorporate a buzzer into your project is with the active buzzer. The downside of the active buzzer is it's either on or off and it makes the same sound either way. The passive buzzer, you can control the tone of it. All right, so that's the advantage of the passive buzzer. The disadvantage of the passive buzzer is you can't just go in and turn it on. You have to use PWM and you have to set a frequency, and that frequency of your PWM will control the tone. So if you just want something that beeps, your best bet is the active buzzer. If you want something that you can control the tone of, the pitch or the tone, then you want to use the passive buzzer. I'm going to show you how to use both of them today, and we're going to be hooking up the first one, the active buzzer, which is the easiest, and then we'll switch over and we will use the passive buzzer. All right, now what I should tell you is that a little bit, there's another very important component that we are going to be using. The other things that you're going to need in the project, you're going to need the Raspberry Pi, you're going to need the 40 wire ribbon cable, and then you're going to need the Sunfounder breakout board. Okay, you are also going to need this P-type transistor. This P-type transistor, and I should probably say a little bit about why we need the transistor and say a little bit about how a transistor works. So I'm going to come over here and bring up a schematic on top of what we're doing here. Okay, and The transistor, so you can see what we have is we're coming off of GPIO pin 17. We have a 1K resistor, and then it goes into the transistor. You can see the transistor has 3 legs. We are coming into what is called the base of the transistor. The leg with the little arrow is called the emitter of the transistor, and the leg that doesn't have the arrow on it, that is the collector. So you've got base, emitter, collector. What a transistor does is it takes a small current and it amplifies that current by 10, 50, 100. So a transistor is an amplifier. Now, why do we need a transistor? Really, those GPIO pins on the Raspberry Pi are not to power something. They're to control something. Now, yes, we did power the LEDs by turning them on and off, but the LEDs are very low current devices. You can very easily burn out a channel, burn out a GPIO pin on the Raspberry Pi if you try to draw too much current. And so if you hooked a motor up to pin 17 and then tried to run that motor, you're very likely to burn out that GPIO pin, if not completely fry your Pi. And we don't want to do that. So how do we do it? We get a control signal from the GPIO pin. We amplify that control signal with the transistor, and then the output device, the motor, or in this case the buzzer, is controlled through the transistor. Its current is going through the transistor, not coming out through the GPIO pin. And so if you look at this, we have a 1K resistor, and then the voltage drop from the base to the collector is very, very small, okay? And so what current would you have? You would have something like 3.3 volts, which is what the GPIO pin is, divided by 1,000 ohms, because we're using a 1K resistor. So you're only drawing 3 milliamps. You're only drawing 3 milliamps from the GPIO pin. But that 3 milliamps is amplified, and the current going through the buzzer will be something, much larger than that, like 300 milliamps or 30 milliamps. Now, if you were really driving something big like a motor, you would not hook the 3.3 volts up to the power supply of the Raspberry Pi. But for a small motor or a buzzer, you can actually run it off the 3.3 volt supply. But this same concept, if you have something bigger, like a bigger buzzer or a motor, you could power it through not the 3.3 volts on the Raspberry Pi, but you could power it by an external power supply. If you use an external power supply, know that you have to hook all the grounds up. So the grounds of the power supply have to be hooked up to the ground of the Raspberry Pi. So in a circuit, all your grounds have to be hooked together. Okay, but in this, since we're using a small buzzer, we will be powering it off the 3.3 volts on the Raspberry Pi, the 3.3 volt supply. Understand that those GPIO pins really should only have a very small amount of current, but the 3.3 volt supply, which we are getting right here, the 3.3 volt. Let me turn this back on. The 3.3 volt output is a larger current device. So we are going to be getting our power from 3.3 volts. We are going to be controlling the device through the GPIO pin 17. Small current from there. The real power to run the buzzer is going to be coming from the 3.3 volts. This is very, very, very important because you don't want to burn out your Pi. So I need you to go ahead and hook up your breakout board. You can see I've got a couple of wires in here to help me with the build, but basically we're using pin 17 to provide the control signal. And then what we're going to actually try to be hooking up is this circuit here. And this is just a physical implementation, a physical realization of the circuit schematic that we have over here. Does that make sense? I hope it makes sense. So what I'm going to do is I'm going to switch over here to the board build. And now we're going to start trying to build this. A couple of things that I want you to see. I want you to see here in my circuit, I have already powered up the 3.3 volt rail from the 3.3 volt pin on the Raspberry Pi. It comes all the way across this second to the bottom row, and then I jumper it up to the top row so that the top row is also 3.3 volts. Then I've got the second row, the ground rail, I've got it connected to ground on the breakout board. So this whole row, the second row, is ground. I jumper that down to the bottom row, and so the bottom row is ground as well. And so what that means is the row that's labeled plus, all along that whole row, I've got 3.3 volts. This one that's labeled plus all along that row is going to be 3.3 volts. This is going to be ground, and this is going to be ground. So we've got that set up, and now we're going to try to put together this circuit here. And remember, that is a 1K resistor, and I got the 1K resistor out of the Sunfounder kit. Now we're going to start with the active buzzer, but I think we'll start with the transistor, and this transistor is in your little goodie bag in the Raspberry Pi kit. But make note, there are two different types of this little transistor device. There are two different types, and it says what type it is on the flat face. It is it is almost impossible to read, so I use this magnifier, and I can see that this is the S8550D331. So you've got to make sure that you get the right one. And let me warn you, that other one has almost identical markings. I think it's an S505 or something like that, but you've got to make sure that you have the S8550, and then it says D331. Now, when you put this in your circuit down here, what you want is you want the flat side pointed towards you. The flat side is pointed towards you. Then the left leg is going to go to the buzzer. As you see up here, the left leg is going to go to the buzzer. The middle leg is going to come through a 1K resistor down to your GPIO pin 17, and then the right leg you're going to ground. Okay, the right leg you are going to ground, if that makes sense. So I'm going to come in here, and I'm going to go ahead and hook it up. You can see that I have a leg that is already going up to ground. I have a leg that is already going up to ground, and so that is going to be my right leg, is going to be the one that goes up to ground. So I'm putting my right leg to this little yellow wire that hooks to ground. Now the middle leg needs to come down to the GPIO pin 17 output through our 1K resistor. So I've got the 1K resistor, I connect it to the middle leg of the transistor, and then I put the other leg of the resistor down there connected to pin 17, the wire that goes to pin 17. Now what you can see is the left leg of the transistor is going to come over, and then I need to put that on the minus. I need to put that on the minus side of the active buzzer. Now what you can see is on the active buzzer, one leg is labeled plus. Okay, one leg is labeled plus. What is the negative leg? One leg is labeled plus. What is the other leg? The other leg is the minus leg. And the minus leg, the shorter leg, needs to come over here to the transistor. So I need to put the negative leg here and the positive leg here, because you can see this wire here is taking me up to the positive rail. So I'm going to pause a second to just let you get that. And I hooked mine up it's the same schematic, but I grabbed some of the things off the top rail instead of jumping over to the bottom rail. So I am going to put the positive leg to the brown wire that goes up to my 3.3 volts, and I'm going to put my short leg, my negative leg, into the wire that goes back to the transistor. And so get that hooked up, be kind of careful with it, and then also make sure this resistor is in good, because it's kind of hard to get a good connection. So at this point, I think we have it hooked up, and I think we're ready to come over to the Raspberry Pi, and I think we are ready to start coding. And so basically, this is just really simple. We're going to put an output signal to GPIO 17, and then the transistor is going to amplify that current, and then we're going to have an audible beep. We're going to have an audible beep coming out of our active buzzer. All right, so let's switch over to our code view, and it will take me just a second here. Switch over to our code view, and then what I need you to do is go ahead and fire up Thony. So you come up to programming, and you come down to Thony. And then that thing pops up with an untitled. I'm going to go ahead and save this. I'm going to save it as passive, or this is the active. This is the active beep, activebeep.py, activebeep.py. Boom, now we're ready to begin programming. Well, we're going to be using a GPIO pin, so we are going to need to import rp.gpio, okay, as GPIO. Now we need to import time, because we're going to need some delays in there. Now we're going to need to define our buzz pin. What is our buzz pin? It is pin 17 in the BCM numbering system. We need to tell it that we're going to use the BCM numbering system by doing a GPIO.setMode, and we're going to set it to GPIO.BCM, because the breakout board on the SunFounder kit, uses the BCM numbering system. So now it knows what numbering system we're going to do. We need to go ahead and set up that pin. So we're going to say GPIO.setup, and then what are we going to set up? We're going to set up buzz pin, and then what is it going to be? A GPIO.out, because we are sending a signal to it. Now we're ready to go, so I'm going to set up my try and accept, and then I will put here my loop while true. When is true true? True is always true, so this will create an infinite loop that will keep looping until it sees the keyboard interrupt, the Control C, and then it will jump down to accept. And then what do we want to accept? We want to accept on keyboard interrupt, like that. And then what do we want to do on interrupt? We want to do a GPIO.cleanup to clean up our pins, and then we want to do a print to make sure that we know that it got down here, and we're going to say GPIO good to go, and that just tells us that we've cleaned up our pins, that we actually got down there successfully. Now we need to come up and write the actual program, which will be in this loop, and this is very simple. I'm just going to say GPIO.output, and then what do I want to output to? The buzz pin, and then what do I want to output? GPIO.high, like that. And then I want to, let's just say that we'll leave it on for 1 second. So time.sleep of 1. Okay. Now, after we buzz, we then want a GPIO.output. Where do we want to output buzz pin? What do we want to do? We want to take it low now. GPIO.low, like that. And then we'll leave it off for a second as well. Could it really be that easy? Do you think that perhaps I could have made a mistake in here somewhere? I hope not. We're going to try to run this, so please hold your breath. good to go. I didn't put my closing quote. Okay, the real problem is someone out there didn't hold their breath. You know who you are. Please hold your breath this time. Ooh, set mode. Man, did I get sloppy here? All right, hold your breath. Boom. Giddy up. Can you guys hear that? It is almost an ear-piercing alarm. So you could really set an alarm like this. Okay, we'll Control C out of that. You can play around with the delay time that you want. We could put, instead of a 1, we could put a 0.1 like that. 0.1. Okay, and now let's run it. I hope it's picking it up on the microphone. It is quite loud. Okay, so do you see how easy it is to add an active buzzer? You just turn it on and off, and then you are good to go. But what we really want is we want to also look at, what if we wanted a fancier alarm, like something more like a siren, okay? Well, what we would do is we would take our active buzzer out. I'm going to put the lid back on it. I'm going to put the little cover back on it. I'm going to move it out of the way. And now I'm going to get the passive buzzer. Same thing on the passive buzzer. The positive leg is shown here. In this case, my legs are the same size, but you can see on it, the positive is going to go to the brown wire, and then the negative, the other leg, is going to go to the yellow wire. So now I have that in there. Let's just see what happens if we try to run a passive. Let's see what happens if we try to run a passive buzzer with just a DC signal. Nothing. Maybe you can hear a slight clicking, but there's no buzzing action happening. Why? Because for this, we are going to need, I'll Control C out of that. For this, what we are going to need is we're going to need to do PWM. So let's come back over to our code view. Let's come back over to our code view. And now I'm going to change this. I'm just going to save it as, because a lot of this is going to be very similar, I'm going to save this as passive beat. Passive beat, like that. Okay, now we're going to modify this code for a passive buzzer. Well, still we want to import RPI GPIO. We still want time. We still want pin 17. We still want the BCM numbering system. But this time in the setup, we're going to go ahead. We're going to set it up as an out. That's correct. But what we're also going to have to do is we're going to have to create a PWM object. And I'm going to call my PWM object a buzz. And then that is going to be equal to GPIO.PWM. Where are we going to do it? On the buzz pin, like that. And we have to set an initial frequency. I'll set a frequency of 400. That should be good. And now I want to go ahead and start the buzzer. And I'll just say buzz.start. And I'm going to start it at a duty cycle of 50%. All right. Now, if we just ran this and didn't have anything else in the code, what it would do is you would have a 440 hertz signal, audible tone with a 50% duty cycle. Now, in the other times when we were doing PWM, we were changing the what? The duty cycle. We're not going to change the duty cycle because what does your ear hear? Your ear hears frequency. What are we going to need to change? We're going to need to change the frequency. But let's see if I could just go ahead and what I'm going to do here, let's just see if we can buzz it. Okay, let's just see if we can buzz it. And so that should already be okay, what I would do down up here, I'm going to go ahead and change this back to 1 second and 1 second like we had it. And then what I'm going to do is I'm going to say GPIO dot change frequency, And then what am I going to change the frequency of? I don't have to tell it what I'm going to change the frequency of, because buzz, yeah, it's not GPIO. I'm going to take buzz and I'm going to change the frequency, and I'm going to change it from what? Let's say I change it from 400 to 100. Okay, I'm going to leave it there for 1 second, and then I am going to come here and I am going to buzz change frequency, and then I'm going to change it back to 400. Okay, and now I'll leave it there for a second. So I should hear a 100 hertz signal, a 400 hertz signal, 100, 400. So it should be sort of almost a little bit of a siren type effect. Do you think this will work? Let's see if we can make this thing work. Ooh. What did I do wrong? Boy, I've really got it messed up now. That sure looks right. I set the frequency to 400 and a 50% duty cycle. Okay, let's completely kill out of that. Let's try it again. Okay, let's Control C. You know what I think is, I think that maybe I didn't completely, for some reason, release that GPIO pin, or it doesn't seem to want to go from a standard output. It doesn't seem to want to become a, PWM pin. Let's see if I just kill Thony and come back and start it again. Unexpected result, but we learn from our mistakes. So let's bring it back up. Okay. And now let's see if we run it. Okay, it's still thinking that thing is already in use. Keyboard interrupt, accept keyboard interrupt. That looks good. GPIO cleanup. It's just not exiting out properly. I probably have an error, and you guys probably see it, but I'm going to go ahead and I'm going to reboot the Pi. If all else fails, sometimes you just got to reboot. And let me come here and make sure that I'm on the right monitor. Give it a second to reboot. The GPIO pins, sometimes they're a little bit unpredictable. So let's go back to Thony. And hopefully it'll pop up in passive buzz. Okay, it's on passive beep. And I'm just going to look at my code again. Change, frequency. That was the problem, change frequency. All right, let's try this again. Okay. That all looks good. Let's run it. Can you guys hear that? What do we like about it? We have control of the tone. We have control of the tone. What I notice is it is distinctly less loud. But it is nice that you're getting kind of a siren type effect. It's nice that you're getting a siren type effect. So let me see if I can call something else back up here. I had some notes that I lost on the reboot. And let's see if we can Control C out of that. Yeah, okay, we Controlled C out of it nicely that time. trying to get my notes back. If I don't have my notes, I'll just wing it. Let me move that out of the way. And I think I might have my notes back. I just can do a little bit better job if I have my notes. All right, so what I'm going to do is, instead of just an on-off thing, let's see if we could make something that's a little bit more of a siren type effect. So what would I do? I would say for I in range, and let's go from 50 to 1000, like that. Okay. And then what I'm going to do is I'm going to do a buzz dot change frequency, like that. And I'm going to change it to what? To I. All right. And then let's go ahead and do a time dot sleep of, let's say, like 0.001. We can come back and play with these numbers depending on what it sounds like. Now that's going to go like that. And now we're going to say for I in range. And then we're going to go from 1000 back to 50. And there we will need to go in steps of -1. I think I got to tell it. And then don't forget your colon. All right. And now we're going to say buzz dot change frequency to I. And then we're going to do a time dot sleep of 0.001. All right. Now it should go up and down. It might go too fast. It might not go over enough of a range, but let's see if we can get sort of a siren effect here. Hopefully that's picking up. All right, boom, we got that working. Okay. What if we go from 50 to 2000 and then from 2000 to 50, like that? Let's see what that does. Okay. I don't like how low it's going though, and so I'm going to Control C, and let's go maybe from 150 to 2000 and from 2000 back to 150, and then let's see what that does. That's a nice siren effect. We made a siren. Okay, so you see we could let's see if we can make it go faster. I like to just play around with it. I'm hoping you guys are picking it up. I'm going to make it go a lot faster. Okay, so we made ourselves a siren. All right, guys, we learned some important stuff today, and what we've learned was, and don't go away yet, I'm going to give you your homework, but what we have learned is, it's hard to find my mouse sometimes. There it is. All right. What we have learned is we have learned how to use an active buzzer. We've learned how to use a passive buzzer. We've learned how to control the tone on the passive buzzer. And then we have also learned the very important concept of use. Looks like we got a fire back there. I typically am not too paranoid, but I do live in a house with a grass roof. So when you start seeing smoke, you get a little bit concerned. Just saying. The other thing that we learned is we learned the very important concept of don't use a GPIO pin for power. You use a GPIO pin for control. You power a device from an external power supply, or if it's not too big, you use the 3.3 volt or the 5 volt on the Raspberry Pi. But don't use a GPIO pin to power things. All right, what is the assignment? The assignment is going to use this and the things that we learned earlier. And what you're going to be doing is you're going to be making a temperature sensor. Okay, you're going to be making a temperature sensor. I want an LCD display, and I want a temperature sensor, and I want the buzzer. Okay, now what I want is I want an alarm to go off under a condition of, let's say, what if you got to 35 degrees F, you could have an alarm, you could have a freeze alarm that, something's happened and your pipes are going to freeze. Something's going to freeze because the temperature is getting down towards freezing. Okay. Or you could say if it's above a certain temperature, you could give an alarm that you are overheating. Now you can choose whether you're giving the alarm on the upside or you're giving the alarm on the downside, but it needs to be something when the temperature crosses a certain level, you're going to alarm. Now, what I will tell you is I'm going to tell you that you need to have the output on an LCD display. And then I want one other thing. I don't want you to hardwire into the program. I don't want you to hardwire into the program what that trip point is. I want that to be set by a potentiometer. So you're going to have a potentiometer, and that is going to set the set point at which you alarm. What does that mean? Your project has to have two modes. Program mode, where you set the trip temperature, and then monitor mode, where it's sitting and waiting to alarm. How do you go from program mode to monitor mode with a push button? So you're going to have a push button to set the mode. You're going to have a potentiometer to create the set point when you are in program mode, and then you're going to have a display, and when you're in monitor mode, it's going to be showing you what the temperature is. So you could sit there, you could press the button, you could set your trip point, you could press the button again, and then you're going to go to monitor mode, and then you could sit and watch the temperature on your display, and then when it gets above your trip point, then you're going to sound the alarm. All right, that's a little bit of an involved project, but what you got to do is you got to be practicing these skills. You got to be using these tools that we have developed in our earlier lessons. And so this is going to put together, this project is going to, in this homework assignment, is going to put together a whole lot of the stuff that you've learned in the earlier lessons. What I need you to do then is post your solution to YouTube, okay? And then in the description of your homework solution, leave a link back to this lesson. And then down below in the comments, put a link over to your homework solution. And I do indeed look at every single homework solution that you post. Also look in the comments, find someone else's solution, see how different people did things, comment on the other people's solutions. So, we want to continue to try to develop a little bit of a community on this channel. Guys, I hope you're having as much fun taking these lessons as I am making them. If you like the video, make sure you give it a thumbs up. Subscribe to the channel if you haven't. Leave comments down below. All that stuff helps me with the old YouTube juice. And the more YouTube juice I get, the more people that will get to see this video. And that's important because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.